Hello and welcome to day 167 of Daily 5 from Sterling Tuition. 5 maths questions. Number 1. Look at the diagram below. It shows an L-shaped swimming pool. How much further is it to walk around the outside of the swimming pool than to swim around the edge of the swimming pool? Write your answer in the space below. So what we've got here is we've got the outside of the swimming pool here, and then we've got the inside of the swimming pool here. So we need to find the perimeter of the outside, and then we need to find the perimeter of the inside. Now, at first glance, this might look like a tricky one in that you know that this is 10 going all the way across here, but then we don't know what either one of these is. But the key thing to remember is it actually doesn't matter what this and this is as long as it adds up to make 10. So this and this are also going to be 10 meters as well. So we know that this is 10 and this is 10. We also know that this is 11. And it doesn't matter what this and this are going to be as long as this and this add up to make 11. So this is 11, and that means these two here are also 11. So the perimeter of the outside would be 10 plus 10 plus 11 plus 11. So 10 plus 10 is 20, 11 plus 11 is 22, so the perimeter would be 42. Another way you could do this is you could actually give these figures. For example, you could give this a 6, you could give this a 5, but in reality it doesn't actually matter because these two are always going to add up to make the same as this. And it's the same for the inside of the swimming pool as well. So this is 7, which means this and this are also going to be 7. So 7 and 7 is 14, and this is 8, which means this and this is also going to be 8. So 8 and 8 is 16. Add these two together will give us the perimeter of the swimming pool on the inside. So 4 add 6 is 10. And then 1 add 1 add 1 is 3. So now we need to know the difference between these two. So we'll just do 42, take away the 30, which leaves us with 12. Number 2, the diagram below shows a square split into 16 equal parts. Each side of the square measures 20 centimeters. Calculate the area of the shaded area inside the square. We'll write your answer in the space below. Now there's a few ways to do this, and I personally think the easiest way is to split this into sections. So if you notice, we've got, this is one section, 2 sections, 3 sections, 4 sections, 5, 6, 7, and 8. So of this, what we're going to do is find the whole area of all of it. So we'll do 20 times 20. So 2 times 2 is 4, and then add the 2 zeros on. So the whole area of the whole square is 400 centimeter squares. But we don't need the whole area. So of the 8 sections, how many of those sections are shaded? 1, 2, 3, 4, 5. So we actually just need 5/8 of 400. Okay, so simple, divide by the bottom times by the top. So 400 divided by 8. 8 into 4 doesn't go, 8 into 40 goes 5, 8 into 0 goes 0. And then we do the times by the top. So 50 times 5, because we need 5/8. 5 times 5 is 25, and then add the 0. So the area of the shaded part here will be 250 centimeter squares. So splitting it into the different sections and then finding the fraction of the shape that is shaded from the total area, I think is the easiest way to do that. Number 3, so a two-parter here. A, each edge of a cube has length of 11 centimeters. What is the total surface area of the cube? So if we were to draw a quick cube here, and it doesn't need to be exact. So each edge of the cube has a length of 11 centimeters. So this would be 11, and this would be 11, and this would be 11, and all the edges would be 11. So we need the total surface area. So the way to do this is find the surface area, or the area of the front face here. So the area of the front face is just 11 times 11, which is 121 centimeter squares. But on a cube, we've got 6 faces. So we need to take this and we need to times it by 6. So 121 times by 6. 6 ones are 6, 6 twos are 12, carry the 1, 6 ones, or 6 add to 1 would be 7. So the total surface area of all the faces would be 726 centimeters squares. So find the area of the front one and then times that by 6. B. Look again at the dimensions of the cube above. What is the total length of all the edges on the cube? So again, if we were to draw our cube, but this time with all the edges. So quick demonstration. So our cube has got 12 edges. And each one of these edges is going to be 11. So every single one of these is 11. So all we need to do is do 12 times by 11. And 12 times 11 is 132. So the length of all the edges on the cube will be 132 centimeters. Number 4, a box of washing powder normally costs £9.57 for 1. A special offer lets you buy 6 for the price of 5. How much cheaper are the 6 boxes of washing powder in the special offer compared with the 6 boxes of washing powder at the normal price? Write your answer in the space below. This is a real sneaky one, in the sense that what a lot of people will do here is they'll do 6 times £9.57, then they'll do 5 times £9.57, get the answers to both of these, and then they'll subtract them, which would give you the answer. But if you're actually thinking about it conceptually, we've got 6 of these boxes of washing powder. We only have to pay for 5 of them, so we pay for this one, this one, this one, this one, and this one. And this one is the one that we get free. So how much is literally would one cost is all we really need to find out, because you're getting one free. You pay for 5 and you get 6. So that means that the answer here is quite simply £9.57, because it's 6 for the price of 5, so you get 1 free effectively, and 1 free would cost you this much. Number 5, Oscar is describing a quadrilateral to his classmates. It has 4 sides, so obviously it's a quadrilateral, so it has to have 4 sides. It is one set of parallel lines. As soon as I read this second statement, I'm able to stop. There is only one quadrilateral that has one set of parallel lines. I'm not going to tell you what it is yet. It has acute, obtuse, and right angles. Write the name of the quadrilateral. So as soon as you see this statement, it has one set of parallel lines, it has to be a trapezium. Every single time. Now a trapezium can look, not very good drawing this one, can look like this, where it's got the one set of parallel lines. It could have a right angle, it could have an obtuse angle, it could have an acute angle. It can also look like this, where it's an isosceles trapezium, basically like an isosceles triangle with the top part cut off. Still only got one set of parallel lines. It's got acute, it's got obtuse angles. This one doesn't have right angles. But as soon as you see this statement, it has one set of parallel lines. This is the only answer that you can put down. And that's the end of day 167.